All right, so we're going to look at your reference sheet again. So this will stay with you every day. All right, so properties of logarithms. So today we're going to talk about ln. Okay, that is a natural logarithm. Now, a natural logarithm, what makes it different is you know how pi appears in nature? Pi is actually formed, so doing a little review here. Someone measured circles, the circumference, the distance around a circle over and over, and then they would measure their diameter. Goes from side to side, goes through the middle. So they measured circle after circle. Every time they measured a circle, they realized if they took the circumference and divided by the diameter, they got the same number every time. Or if they measured a lot of them, then when they averaged it out, they kept getting the same number. So if you can measure accurately the circumference divided by the diameter, you get the same number. So they called that number that goes on forever and doesn't repeat, they called it pi. And if we multiply by d on both sides, that's how we find the formula for circumference. Now, so pi appears in nature, and you're familiar with pi, all right? So we have discussed already how e appears in nature. All right, so the natural logarithm is when we take a logarithm and we use the base of e. So when you see ln, that just means log base e. So it's really nothing new. It's just using another number, a number that's kind of similar to pi. All right, it's e. All right, so that's the 2.7 we've discussed before. And you'll use a calculator to do that. All right, so everywhere on this reference sheet where you see log, okay, you could write ln. And we know that ln is base e. So if I put an e where this b is, then that is saying ln of x equals y. So down here, if I put an e everywhere the b is, then that is saying we've got ln, because that's log base e, of m times n is the same thing as log, or ln, which is log base e, plus natural log again. All right, so the property is identical. Okay, so there's nothing different about the properties. So everywhere you see the log properties, it means the same thing as the natural log properties, the ln's. Just have to remember that your base is e. Something else we're going to see today is we're going to deal with equations again. Okay, so today, except for the fact that we're using base e, we are reviewing things we've done before. So remember, when there is no logarithm and we end up having a variable that is in the exponent, this gives us guidelines on what to do. All right, but when the variable, when we do have a logarithm, okay, so we do have one and the variable is not in the exponent, then this gives us guidelines. All right, so let's look at this first row right here. All right, so we're going to look at this first row to see what it is we need to know and get used to the ln. So we're going to rewrite this using log base e. Every time you see an ln, we're going to write log base e. So what we just did there, we rewrote ln. Instead of an ln, we wrote log base e. But this e still needs to be written down here also. All right, so we were taking the natural log of e. This right here means natural log, and e is still there. So now we can do a little review also, because the other day we talked about how, let me give you an example. If we had log base 5 of 5, well, the log button on the calculator doesn't work unless it's base 10. And I realize some calculators you can type this in, but let's do it this way. We're trying to figure out what does this equal. So we don't know what it equals. We're trying to figure that out. So this over here, let's call it x. And this is review. So if you want to change that to exponential form, you take the base and raise it to what you see on the other side. Okay, so this base, that's where you start. You raise it to that other side. That would be, this is the exponent, and then that will be equal to whatever was there that we were taking the logarithm of. Well, we know that any number sitting there with no exponent really has an exponent of 1. Since the bases are the same, then that means if these two these two sides are equal, which they are, then the exponents have to be equal. So we know that x has to equal 1. So I can come up here and get rid of the x and put a 1 in its spot. Okay? Now that is not the problem on the worksheet. This is just review. To remind you that when you rewrite this in exponential form, that is your base right here that gets raised to the other side, and this ends up being the base on the other side. Change that back to x real quick. Okay, so this is how it will always end up getting set up from logarithmic form to exponential form. This will be your base raised to that, but the other side of the equation, that will be your base, and there's no exponent there, so that's a 1. So this, when these two are the same right here, it will always be equal to 1. So now let's use that with what we have over here. We have this base is the same as that. So when that happens, we get an answer of 1. If you're not believing me, I'll show you over here to the side. If you're good to go with that, you can forward on to the next. We do the next problem. I'm just going to show you that if we're trying to figure out what log base e of e is, we take the base here. It gets raised to the x, and that is equal to whatever's sitting there, which happens to be an e. There's no exponent, that means it's a 1. So the way to make these two the same, x would have to be 1 to make the two sides the same. All right, so continuing. Let's go over here to number 3. See how that works. On number 3, we have an exponent out there. We can move that exponent out to the front, property D. Actually, back up. We're going to do that differently. All right, we're just going to change this. We're going to rewrite it as log base e. Not really solving so much right now. That's not the important part. We're just trying to get used to log base e. Got ahead of myself. All right, so we're going to write this ln as log base e. Notice the e squared is still over here to the side. All right, now that we see this base right here, all right, now we can use property, go back, see your properties, D. We're going to use property D if you want to look at it for a minute. That's the one that takes the exponent up here and it moves it out to the front. All right, so we're going to take that number and we're going to move it out to the front. So that 2 ends up out here, and then we have log base e of e. And we know that log base e of e is 1. So since this part is 1, since this part right here is equal to 1, 2 times 1 we know is 2. Now let's try number 4. So we've got this 10 over here. And we know that ln is the same as log base e. And then we've got an e back here. That's what we're taking the logarithm of. we know that log base e of e is 1, so we get 10. Number 5, in the numerator, we've got ln of e, so log base e of e all over 4. And we know that log base e of e is 1, so that's just 1/4. And now we'll go back to number 2. When we rewrite this, log base e of 1, well, the little base e down here, that's not the same as this, all right? So we're not doing the exact same thing. So let's set this equal to x so we can figure out what that equals. And I'm going to change it to exponential form. So the base is e raised to the x, and that equals 1. So now you need to go back and think about what number needs to go here so that you equal 1. So think about there's a certain number that no matter what number is right here, no matter what number is there, when you raise it to a certain number, certain exponent, you always get 1. And hopefully you're remembering that that number is 0. So as a little review there, anything to the 0 power, 5 to the 0 power, it's 1. Pi to the 0 power would be 1. Okay, e to the 0 power is 1. So that's what we just talked about. All right, on number 6, now we're going to write these as a single natural logarithm. So we want to write it as a single. So let's go back and review which ones are the singles. So the single logarithms are on the left side of this sheet. Okay, so I put the word single first, remind you that's the left side, and then expanded forms are on the right side. Okay, so we want it to look like the left. We do not want to leave it with something being added or with 2 logarithms being added. We don't want to leave it with 2 logarithms being subtracted, and we don't want to leave a number out in front of the logarithm. All right. So number 6. We have a number out in front of the logarithm. We don't want that, so we're going to move that back here as the exponent. That is property D. Property D is the one that allows us to do that. Remember, with an ln, it's still a logarithm, so it still follows the same rules. So natural logarithm of 3 to the 4th. And if you go over to the side, 3 times 3 times 3 times 3, instead of grabbing a calculator or having to take, I'm going to show you a little different way to do it. We're going to take 3 times 3 is 9. Instead of taking 9 times 3 to get 27, then multiply by 3 again, 3 times 3 is 9 again. And then 9 times 9 is 81. That might be a little bit easier. Whoops. A little bit easier to think about. So that would be your answer. All right, so these in the middle, we have 2 logarithms being subtracted. We can't deal with that. We're not going to leave that. We want it to be a single logarithm, okay? A single logarithm. Also, it says natural logarithm. So if you did change this to log base e, you need to change it back to the natural logarithm for your answer. All right, so when we have 2 logarithms being subtracted, we can write that as 1. When they're being subtracted, you actually take those 2 little parts and you divide them. So 18 divided by 10, if you put that in simplest form, divide numerator and denominator by 2, just wrote the wrong number, by 2, you get 9/5, or 18 divided by 10 as a decimal is 1.8. So either one of those will be fine. When we're adding natural logarithms, you look at the properties, you multiply the 3 times the 4. So this is natural logarithm of 12. This one over here, we have a number out front, so we're going to move it back there to the exponent again. So Back here, the -2 ends up being the exponent. And we know that to get rid of a negative exponent, you move it to the other part of the fraction. When you do that, the exponent becomes a positive. So we're going to have natural logarithm of 1/4, which is the same thing as the natural logarithm of 0.25. So either way. Number 10, we're going to solve this. So if you go back to your solving equations, this first one says no logarithm, and the one down below says logarithm. Well, we have a logarithm in our next problem that we're looking at. All right, so we're going to look at the properties, use the properties, write it in single form, and then we're going to change it to exponential form. So when we have a logarithm, that is our goal. Single, then exponential. So we've got a logarithm. We want to write it single form, which it already is. All we have on the left side is a logarithm. There's nothing being added or subtracted with it, or multiplied or divided. All right, we just got natural logarithm of 5x. We don't have two logarithms being added, we don't have two being subtracted, and we don't have a number out here in the front. So it is a single logarithm. So we're going to change it to exponential form. Remember, our base is e, and that is raised to the 4th power, and that is equal to 5x. To solve this, we need to get x by itself. We're going to divide both sides by 5. And then you're going to type that in your calculator. You do have to be careful that when you type in your calculator, you're going to be second function, then ln. That will take you to the e. When you fill in the box with 4, you have to use that right arrow to get out of that exponent before you can divide by the 5. And again, we are rounding it to the nearest 10,000, so it's going to be 4 decimal places. So that's going to be your answer. Number 11. When you look at that, a lot of people are thinking, oh, we don't, it's not in single form because we've got subtraction. But you only have one logarithm over here on the left side. It's not two logarithms being subtracted. So if you go back here, see how this has two logarithms being subtracted? We don't have that. So we actually already have a single. So we'll be able to change that. All right, so it's a single logarithm. There's nothing outside the logarithm being added, subtracted, multiplied, or divided. So we can take it to exponential form. Remember, the base for natural logarithm is an e. You raise it to the 2nd power on the other side, and that's going to be equal to that x minus 7. To get rid of the 7, so that x is by itself, we will add 7 to both sides. So don't forget that, again, when you do the second ln button, that's what gets you to the e. You'll type the 2 in, then use that right arrow to get out of that exponent so you can then add 7 to it. And when you do that and you round it to 4 decimal places, which is the 10,000ths place, you find that that's your answer. I'm going to go down here to number 13. We're going to do the same thing again. Actually, no, we're going to number 12. Number 12. We're going to do the same thing again. This is property D is what we would normally follow here. But this, number 12, has an exception to the rule, all right? So don't do it this way. I'm going to show you, because if you follow those rules that I talked about on the other side, not the rules, but the guidelines, you would normally make this a single logarithm. So you'd take that 2 and write it as an exponent. And then from here, you would put e to the 4th, because that's your base, equals x squared. To get the x by itself, you would square root, but when you square root the other side, you'd put a positive negative. Again, don't do it this way. There's an easier way to do this one. Square root of e to the fourth is e squared, or you may have just typed it in and you've got this number sitting there. The number that you would have sitting there would be 7.3 and some other stuff, all right? And that would be your answer. But if you go back and check, you will remember that this negative number, if you put a negative in there, oops, wrong one. You put a negative in right there, you cannot take the logarithm of any kind. You can't take the logarithm of a negative. You'll get an error. So this negative ends up being an extraneous solution that we don't even want. So it ends up just being a positive 7.3 and stuff. Now, there is a better way to do this one. If you have 2 times ln of x equals 4, if you are trying to get that x by itself, you're trying to get rid of stuff that's with it. The 2 is out front being multiplied. So we could actually divide by 2 and make that 2 go away. So once that cancels, you have ln of x equals 2. Now we could write it as an exponential function. Your base is e raised to the second power, and that's equal to x. And when you type in e squared, you get 7.3891, which gives you the same answer as the other method, but you'll have to be on your game and remember that that negative number that you'd be plugging back in right here, you can't take the logarithm of a negative. So it actually doesn't work, all right? So people usually prefer this method over here. So if you are looking at, let's go look at these for a minute. If you're looking at your properties, all right, so we had a logarithm, all right, and it says to put it into single basic logarithmic form. Well, you probably actually want to just do that if you're dealing with B and C, all right? If all you've got is a number out front right here, if you've got an equation, you could just divide both sides by that number. All right, the last one I'm going to do with you today is going to be number 13. And that one, if you look at your reference sheet again, that does not have a logarithm. Going back to the reference sheet again, that has no logarithm. So that's where we'll try to get the same bases. But if we can't, then we're going to take the logarithm or the ln of both sides. All right. So we are going to first try to see, can we write 12 with the base of e? And you can't do that. E is 2.7. If you start doing a factor tree, you will not have e times e or anything like that. Cannot write 12 as a base of e. So the other day what we did was we took the log of both sides. And that will work. That will give you the right answer. All right. But if you take the natural log of both sides, wrong color. You take the natural log of both sides, something nice will happen that saves you a step. Again, you could take log base 10 of both sides and still get the right answer. But you're going to like kind of how this works out here in a minute. So we're going to move that out to the front. So then all we have left in here is natural logarithm of e. And we know from earlier that the natural logarithm of e is 1 because the base was the same as what we were taking the logarithm of. So now 2x times 1 is just 2x. And then when we divide both sides by 2 to get x by itself, Instead of typing in earlier, if we would have done log base 10, you would have had to type that logarithm in and then divide it by that logarithm and then also divide by 2. So this way, this is all we'll have to type in. So when you type in logarithm of 12, natural logarithm of 12, so make sure you hit the LN button, close that parentheses, and then hit divide by 2, you're going to get 1.2425. So just be careful in your rounding.